Hi, so let's get started. We have, well, at this point, not many people um, on the live stream today, but that's not a big problem. Um, Today is going to be interesting because we'll do a little bit more structures and then I will make a linked list. Now, linked lists are one of those topics which people find a little bit scary to start with, but hopefully you will see today that it is nothing to be afraid of. It's a very elegant data structure that can be used for a wide variety of applications. So today I will spend some time working out a more complicated structures example than we worked out last time, and then I'm going to convert that structures example into a linked list example. That is my plan for today. I'm not going to be solving the problems that I have given in the practice. That's sort of assuming knowledge of linked lists. So today is an intermediate tutorial essentially, where I will actually figure out for you how to implement your first linked list in a reasonable way. So let's begin. And let me tell you what I plan to do first. What I plan to do first is write some code that should be fairly close to your hearts right now. Write a program to construct a data structure to store ESC101 marks and grades. And what I want to do is the program should have the ability to set grades based on grade cutoffs and print all data to terminal. This is something straightforward. And let me wrap it around. Okay, so this is what I'm asking for, and this is again not very hard. Let's figure out what our program is supposed to look like. So first of all, this is a structures program. The simplest thing to do is to say, well, let's get the boilerplate out of the way. Include stdio.h, and we'll say int main return. So that's the boilerplate out of the way. And now what is the structure we will define? Struct student, and what will we call this? So the student has a name which has to be a string. Let's say nobody has a name that's larger than 50 characters. You have a roll number. It's probably too long to be an integer. Let's say it's a long. Your marks are a float variable. I'm just assuming this is the total that we're dealing with. And then the grade is a letter, so that's just a character. So we'll say struct student. Now if we say struct student, then what do we have now? We can say struct student s1 comma s2 comma s3, and then I can do data entry for these entities individually. What I have is I have a custom data structure of type struct student. Now this can get a little clunky, so I'm going to show you today what I promised I'd show you before, which is how do you make this simpler. So what you do is you can use typedef to define this structure as another structure. To define this custom data type as to have some label. So the syntax of typedef is, if I wanted to say I don't want to say int, I want to say pint. I would say type def int pint. It is a statement. And now I can say something like pint a. Now this is a stupid thing, so I wouldn't do this, but this is the syntax of type def. And with this, I can now say student S1, S2, S3. So where I before had I had to say struct student, now I can just say student. Or I could just say S. Nothing is preventing me from defining it this way, except that this is not very meaningful. So let's just call it student. So you understand what the syntax is. The syntax is you take a data type that you already have defined and you just call it something else, and you put a colon at the end. Now here I had defined, or I am defining, this novel data type, struct student, followed by everything till the curly bracket close. So I am just wrapping that into this type def statement, and so I am saying type def struct student, and now I am able to say student S1. Now this has an advantage, which is that I can do assignment of this very simply. I can say uh, 54.3, and I will say the grade is still empty, and I can do the same thing for other students. And so on. I'm just doing it for 3 because we want to keep moving. I can do this assignment line. Well, I can initialize and I can assign in the same step, instead of having to write a new function to get all these data values into the fields of this array. Although I will show you a more elegant way of doing this also, but this much is going to work. So now we have a program which is defining this type, and now the one part that I haven't yet done, but which I should do, is print this out. So if I'm going to print out a student's details, I will say void, because I'm just printing. And now what are the parameters that I need? In this case, I'm just going to pass the structure by value. So if I pass the structure by value, I just have to pass something called student S. And in this, I will be able to say print name s dot name. So the name field will be printed out here, and similarly for all the others. Let me just quickly run through them. Roll number is a long s dot roll number, and marks is a float. Let me specify the format, marks. And finally, grade is a character. Okay, and let me just say return for completeness sake. Now I have this. Let me just put this here. I have this, and let's see if it actually works. So I will say print data s1, S2 and S3. This should print out everybody's data, and let me say gcc demo1.c minus o test.exe. Okay, it works. Now let me run the code. So you can see that this works just fine. I am able to print out all three names. Oh, the roll number. What do I need? Oh, it should be long. Okay. Now it should work. Yeah. So I missed the placeholder. Now it works. Now I am able to print out the name, roll number, marks, and I haven't yet set the grades. I want the grades to be set programmatically. So that is what I am going to do next. I am going to write a function that will set the grade. So let me call that function set grade. And what is the return type of this function? So for now, let me just do it the easy way. I will say the return type is student, which means that I will pass a data type or a variable of type student into this by value, and it will return a data type student from this. So this we can do with a simple if else is greater than 65, s dot grade equals a, oops, else if s dot marks greater than 50, s dot grade equals b, else if s dot marks is greater than 35, s dot grade equals c. In case any of you are getting worried that these are the actual cutoffs, they're not really the actual cutoffs. They may be, but that's not set in stone. I'm just putting down whatever comes to my head. Return. Say. So this is a function of return type student, and remember that this return type student is something that we have idiosyncratically defined using type def. So now with this, what can we do? We can say we can say set marks. So because we are returning this, oh, did I say set marks or set grade? I said set marks. I shouldn't say set marks. I should say set grade. So I can do something like this now. Set grade S1. Oops. So S1 is the structure that has this information in it. It does not have the grade information, but then I pass it into this function set grade, and what this function returns is, oh, it should return S. Yep. And then what this function returns is a variable also of type student where the grade has been set to some value, which is exactly what we want. So that will do. and that will do, I think. Let's see if this compiles. Yeah. cls gcc demo1.c test.exe. Okay, and now let's run it. There you go. You can see this works perfectly. Grade B, grade S, and grade A. So here is a slightly more complicated example of structure use than what we did last time. What we did last time was we just used a structure which had these two parameters or two variables left and right, and we just figured out how to set them and how to do some basic arithmetic with them. Now I have shown you a slightly more challenging, well, it's not really challenging, but it's, you know, it's a little bit trickier. So where was I? So here I have shown you how to use type def so that your code no longer reads as clunky as this code was reading. You know, struct interval, struct interval, struct interval. I could just have replaced this with struct interval, and then I would put interval here, and I could just replace struct interval with interval everywhere. Where was I? I don't need to see this anymore. So this code is slightly more advanced than what we did last time. We are using a more complicated structure. We are doing a number of operations with this structure, and we are passing it to and fro, and we're printing it out. So that's good, and now we know how to do this. Now suppose I said do this same exact thing write a program to construct not a data structure in general, construct a linked list to store ESC101 marks and grades, and I want all these other parameters to be satisfied just as well. Now how would we do this? So conceptually, what is a linked list? A linked list is, I mean, everybody says node, let me not say node. Let's say I'm just saying struct A. And now this struct A has, let's say, int x comma y, two data points. Let me say it's struct point. Okay. And this is a simple structure. We've seen structures like these already in all the code that we were writing. See, this is very much like that. So what makes the linked list special is that you also have a declaration of a structure pointer of the same type, struct point, in the definition of your structure. It's a self-referential definition. This is what turns a regular structure into a linked list. Why? Because this way, what I can do is I can say I can read the data in this block of the list and then go to the address where the next block is stored. So remember, this is what we do with arrays. With arrays, this happens automatically. I'm able to read the input in one block, of this of memory, and then the compiler, not the compiler, but the computer automatically knows where the next block is. It knows automatically where the next block is because in arrays, memory blocks are contiguously assigned. They are next to each other, so it's not rocket science to know where the next memory block is going to be. But this means that for large arrays, large memory blocks have to be free to begin with. Now this may not always be realistic. So that is why it's good to have more flexibility such that you specify within your program how to jump to the next block where information is stored. You jump to the next block by pointing to it. So you have a structure, it has some data types that form part of it. Now this structure is of a certain type. Let's say it's of type struct point. So what will be the type of variable that will point to a data type of type struct point? A struct point star, a pointer of type struct point. So that is why we declare a pointer of type struct point within the definition of struct point. That is what makes this a linked list, or that is how you implement a linked list that would use this data structure. So that's a quick summary of what a linked list requires to begin with. Now, we don't want this. We want our old structure. Let me get rid of all of this. Let me just copy paste this over. We want to convert this structure into a linked list, or we want to use this structure while working with a linked list. So what do? This is what we do. We say struct student star next. That's all. This is all we have to do. What did we have before? We had this structure without this line. Now I have added this line, and what this is going to do is it is going to construct a variable that is going to store the address of a location, and it is going to say what is stored here: a block of information which has a string, a long, a float, and a char. That is what this is going to store. It's going to store a pointer to that address to it. So we can have multiple memory blocks of type student now in memory. This is the way this works. Let me put in the header files before I forget. So we'll need this. We'll also need cd lib because we're going to be doing dynamic memory allocation, and you will see we will also need string. So these are the three that we will need. But now let's go step by step. I know lots of people who get just frustrated with linked lists and then just give up on the course at that point. So let me go slowly and make sure that everybody is with me as we go further. So now I have this int main, and I have this structure which has this self-referential pointer declaration. So what can I do now? What was I doing before? When I was just working with a static structure, I was saying student S1 equals ABC, comma 190001, it's one too many, comma 54.6, comma whatever grade is going to be set. But now I realize instantly that there's a problem. What is the problem? How do I specify the memory pointer? If I assign the variable like this, I have no control over where it is stored, and I have no real visibility over where it's going to be stored. So one solution is to say that. Now what is this going to do? It is going to say that this node is not yet assigned. So we'll just store null. Null means there's no memory. So wherever you want to store a memory address, but you don't know what it is, you say null. So that's one possibility, and I can do the same thing here. And the same thing here. Alright, so I have specified the contents of these three data types, but now how am I going to link them with each other? So this is when you have to link them, otherwise you don't really have a linked list. So one way to do this, let me first compile this. Ls gcc ll-demo.c -o test.exe. It compiles, and let me do the following just to verify that we're going okay. Let me also bring this function over. I'm going to copy this function over just to make sure that we are going okay. In this case, I'm going to call this print record for reasons that will become clear. Print record student S, and I will print one student's record. Okay. So we can see that this student's record prints out just fine, which means that our data structure is the input and the output is working just fine. But like I said, we haven't yet linked the list. These are independent data structures. So what do we do? What we could do is, we could say S1 dot next equals S2. Can we do that? Now what would this line do? This would take the field next for S1, and what would it set it to? It would set it to the address of S2. So I compile this code, I'll run it, it works the same way, but now something has changed. What has changed is I now have a relationship between S1 and S2. The next field in S1 contains the address of S2. So in principle, I could go from S1 to S2 and print all of S2's records also. But how do I do it? So just to complete this, S2.next could be set to S3, and S3.next could be set to, well, S3.next is already set to null, and that's what it should be. So this actually gives you a complete linked list, but I'm still only able to print records like this, S1, and then I would have to say print record S2 and then print record S3. How can I change this? So one way to do this is to say, instead of saying print the record, let me say print the list. Now I have a list, print list. Now what is going to be the address, or what is going to be the parameter to the list? Has to be an address. So what will this do? While s not equals null, that and you can see that this notation now will not work. I have to replace this with what notation? Either I dereference s like this. Remember that now I'm passing an address, so I have to dereference it if I want to use it with dot notation, or I use arrow notation, which is going to work the same way. I have to do either of the two. Both are doing the same thing. Both mean the same. And then what do? I say s equals s next. So what is this doing now? Now I have a piece of code that is running through my entire list. Now in this case the list just contains 3 entries, but it could contain more. And if I said print list and I passed in the address of S1, what will happen? Let's compile this. Let's run it, and you can see that it prints out all these entries, all the 3 entries, and I just had 3 entries, but we could have more. Let me put in some more. Student S4 equals JKL 4, let's say they got 56.2, and S5 and so now how do we link all of these people up? It's very simple. S3.next equals S4, and S4.next equals S5. So now when I print out the list, what do I get? 1, 2, 3, 4, 5. I get all 5 observations. So I just have to print, I just take one print function, this print list function, and it runs all the way through the list, this linked list, and it prints out all the elements. This is the same as having a structure array that you can iterate over, except now we have more flexibility in terms of where the elements are stored in memory. And so that is the value of having a linked list. Now I showed you how to do it this way. Let me show you how to do it in a different way. So before we do that, what was I going to do? What was the last thing I was going to do? Oh yes, I wanted to set the grades also, right? So here you can see that I have this function setGrade to set the grades. Now let's copy this function over, and then let's see what we can make of it. So this is a function that will set the grade for any given record. Now how can we use this to set the grades for all of these entries? Now we could of course say student S1 set grade S1, or S1 equals set grade S1, S2 equals set grade S2, S3 equals set grade S3, and so on. But as you might imagine, that is a fairly clunky way of doing it. So what could we do instead? So think about this. Now we have this list, and this list can be used to print all entries in the list. So then can't we use it this way? Set grade S arrow grade. So what would this do? In principle, this would, while we are looping through the list, or while we are running through the list, we can call this function setGrade to set the grade for S, and then we print it out. However, remember that S is an address. S is not the data structure itself. So what we need to do now is we need to change this. What do we do? So we change this function such that it outputs an address and it inputs an address instead of the value itself. We are passing by reference instead of value. What that means is that wherever you see a dot, you put an arrow. Why? Because this is the arrow notation means here on the left there's a pointer, and the pointer is pointing to a structure, and this field in that structure is what we care about. That is what arrow notation is denoting. So this is my revised function. And now what can I do with this? Let's take a look. Voila! What has happened? I ran through my list and I updated the grades and I printed them out. And because I passed by reference, this information is not lost. This information still stays inside the structures if I do the whole thing and then I try to print record S1. What would I get? See, I have printed out a single record, ABC, the first record, and you see that even though I did not store this in any intermediate variable, I just directly printed this out. But because I'm passing by reference, the change that is made by setGrade, this function, is made inside the original data structure, and so it is updated. So that's cool. Now I have shown you how to make this linked list. I have shown you how to link it. Now let me show you how this is done in a more, well, I won't say more elegant, but you can see that there's a lot of repetition here in this code. And we want to avoid such repetition. So how could we potentially do this? So let's take a look. So basically, one thing we can do is we can say, so here I'm doing static allocation. Now I'm going to do dynamic memory allocation. So what I'm going to do is I'm going to comment this code out, and I'm going to show you how to achieve the same result using dynamic memory allocation. So what do? We say, let's define student S1, comma, star S2, comma, star S3. So I have defined what? I have defined 3 pointers to the student data structure. So I have said I want 3 blocks in memory large enough and structured in the way to hold the student data type. And now what do I need? I need a malloc. What will the malloc do? S1 equals malloc size of, what is the size? Student. And now what should this be cast to? Has to be cast to the type student, right? That's the logic. And the same thing for S2 and the same thing for S3. So this works. Now I have 3 dynamically allocated memory locations that are waiting to hold this data entries that are of the type student. So now because I'm doing this the allocation this way, I can no longer say S1 equals whatever. I can't do this anymore. So now I have to do allocation in a smarter way. What do? I can say S1 dot marks. Actually, I can't say S1 dot anymore, right? Because this is a pointer. So I'll say S1 dot marks equals, let's say 45. Does that work? Yes, that works. What about S1 roll number equals 190001? This is going to work too. Let's say S1 next. What am I going to set this to? I'm going to set this to S2. That is how I'll link, right? And what else do I need? I need S1 name equals, let's say, ABC. Very good. So now instead of what I was doing before, I can do this. Now let me quickly, before I move forward further, compile it. Aha. So you can see that there is a problem. What is the problem? The problem is that I am setting, or I'm saying S1 dash name equals ABC, and I can't do this because the memory block which is expecting the string has no idea how big the string that I'm passing to it actually is. So I mean, this is one of those idiosyncrasies of the compiler that one has to be sensitive of. But when you're trying to write a string to a field, you can't use a direct assignment like this. What you have to do is you have to replace this with something like string copy S1 name comma ABC, and now the compiler will no longer crib. See, it works just fine. And now I can do the same thing, copy paste for the others, or I can be slightly smarter and I can write a function that is going to do this for me. What will the function do? So what I can get the function to do is, what will the function be of, and what will be the type of the function? Since we are writing a bunch of records, we don't really need anything to come out. Let's say input data, and this function has to take two pointers. I'll show you why two pointers as the first couple of arguments, and then the rest are familiar. Star name, long roll, float marks. That's it. And this is going to return nothing. And now what do we put here? Oops. This should be clearly understandable. Marks, roll, and everybody knows what S1 and S2 are. Just hold on, I'm getting a call. Let me just take it. Hang on. Hello. हाँ बताइए प्रशांत जी. हाँ मैं अभी ऑफिस में रुक के कर देता हूँ. नहीं मैं आगे कर दूँगा. ठीक है. हाँ sorry, I had to take that call. So I have this function input data now, and what can I do with it? Now I can say input data S1 comma S2 comma ABC 19001 57.2, and what about the others? Easy. S2 comma S3 DEF 2, this something else. And what about for S3? Just that. So now I have a function that I can use to input these observations, and I already have a function that will print all the records. Let me just use it. What variation, what modification do I need? Just that. I'm passing an address I am already defining S1 as the address, so this should do the job. Test.exe, and there we go. You can see 3 records, the grades are assigned, and I'm printing them all out. And this is taking so much less code than what we were doing before. It's just straightforward. When we get to the last couple of lectures, I'll show you how to actually take such inputs from text files, which will make this even easier. But hopefully you now see how a linked list is a very, very straightforward idea. You just define a structure, and within that structure you define a pointer to the same structure, such that in every entry you are able to say just go to the next one. And so you can roll through your list by using a while loop, pointing to null as a termination condition, and just keep updating the address, and you keep jumping from one block to the next, one block to the next, one block to the next. That's all there is to it. It's like an array, except that it is stored in separate locations in memory. So let me stop here. We've already gone on long. Let's pick this up again on Wednesday, where we will see some more linked list operations, inserting to linked lists, deleting from linked lists in specific locations, and so on. And then we'll actually solve a couple of these problems that I have put up in the structures, so medium to maybe hard if we have time. We'll handle all of them in the next class. So hopefully all of you will be completely comfortable with linked lists after this week is out. Okay, so let me stop today, and we'll pick this up on Wednesday.